In this video, we're going to do some ionic equations. Now, this has come up from time to time throughout the year, and I keep saying we're going to cover it, and now we're finally going to do it properly. The notes that I gave you guys in the booklet, I wasn't quite happy with those. There are a few examples missing, so I've given the relief teacher today a different set of examples, which will be given to you guys, and you can follow along the examples with this video. So, ionic equations are used to show the ions that are crucial to a reaction involving aqueous solutions. So we're talking about these situations where we take two solutions, so two clear liquid-looking solutions, and we mix them together and we get a precipitate. Now, anything that doesn't participate in the reaction is called a spectator ion. And really what this is about is identifying those spectator ions. So let me show you what we do. Use a bit of colour coding here, and I'm going to underline in blue all the aqueous compounds here. And then finally we have our solid compound, the magnesium carbonate there at the end, which is solid with that S there. And the others are all aqueous. Now, compounds that are aqueous, we write these as separate ions. So here we've got the potassium ion, which is K+. And we've got the carbonate ion, which is CO3 2-. So notice I've included the state for each of these. Don't forget there are two potassium ions, so we need to put a 2 there. That seems strange. We'll talk more later about why that is, but the fact is that there are actually two separate ions floating around, so we need to represent it with the 2 at the front. Okay, then we've got magnesium ion, which is also aqueous, and bromine. You'll notice there are 2 of those, so we put a 2 out the front. Which is minus. Okay, then we go to the other side of the reaction and we have 2 potassium. So we need to write the states. That's meant to say aqueous there. We need to write the states for each one, and that 2 pertains to the bromine as well. So all the aqueous compounds we've written as separate ions. But now we come to the magnesium carbonate, and that's a solid, so we write that as magnesium carbonate. Okay, so this is what we call the full ionic equation. So next we're going to write the net ionic. The full ionic's the challenging part. The net ionic's the actually relatively easy. All we've got to do is look at any elements, or I suppose any ions rather, is a better term to use, any ions which are aqueous on both sides of the equation. Potassium, aqueous here and aqueous here, that's a spectator ion. As is bromine. Now the magnesium and the carbonate are aqueous on this side, however they form a compound here. So the net ionic will be that really, essentially what's happening is a carbonate and a magnesium, which are in solution. When they're mixed, they form this solid. And that's actually what's happening. The potassium and the bromine are really just watching. They are spectator ions. Okay, So this is our net ionic equation. So let's try it for this one. Now my apologies here. These should be subscript 3s. Oh, I wanted that in black actually. And there should be an arrow between here. Pardon me. Okay, so no states on these either. So we've got solid, sorry, that's not right. We've got sodium chloride, which is aqueous, and silver nitrate, which is aqueous. Now we know all nitrates are aqueous, so this sodium nitrate will be aqueous, but the silver chloride, if we look up our table of solubility, and you should check this, silver chloride is a solid. Okay, so the full ionic. First, go ahead and write these all as separate ions. You might want to pause the video and try it on your own now, then I'll do it. Okay, anything that's aqueous, these guys, sodium and chlorine and silver and nitrate, and they're all aqueous. We need to include the state, and then that becomes sodium nitrate, so Na plus, which is aqueous, and NO3 minus, which is aqueous. Now I'm just running out of room a bit here, so I'll need to put the solid silver chloride down here, and that's written as a compound, a solid compound. So now, next task is to identify the spectator ions. So you might want to pause the video and try that yourself. Let's do it. Sodium is aqueous on both sides of the equation, and nitrate is 2. So the net ionic equation is that chlorine and silver form silver chloride. Okay, now go ahead and try some of these other ones, or this last one. I won't do this in this video, but when I get back, we'll check the answer to this one together. In the video description, I'll put some questions that are in the pink booklet for you to try, and you'll be able to get feedback on those by checking your answers, and perhaps the relief teacher will know how to do these, and maybe you can check those with the relief teacher today. Check this reaction. The difference with this one, of course, is that it's written as a sentence, so you need to identify what barium chloride and magnesium sulfate are, what their chemical equations are, and same for the barium sulfate and magnesium chloride. But then once you've written that equation down, so the full equation will be just writing this as a chemical equation, go ahead and write the full ionic and net ionic equations down. So this is a challenge, but I'll leave it with you, and we'll catch up on Tuesday and see how you went. Okay, well done.